And when I give you a nod, I'll finish my intro. Morning, everyone. Should I say morning to a bunch of teenagers? Maybe it's afternoon by the time you lot watch this. But anyway, thought I'd make a change and give you a nice little video lesson this week. A nice little lesson. Whether you lot regard it as nice, we'll wait and see, because there's some quite difficult challenges here. Anyway, get yourself prepared. First, be a good scientist. Pen, paper, periodic table, calculator, all to hand. Pause for a minute whilst you get those and continue once you're ready. Right, series of 5 questions for you in this video, each one broken down into several parts. Here's question 1. For the reaction shown here, 1A, can you write a chemical equation? Pause the video, have a go, continue when you're done with that. Right, hopefully that wasn't too much trouble and you've come up with this. Now, the next challenge, one of those awful Ionic equations. What am I saying? Awful. They're lovely, aren't they? A lovely Ionic equation. You all love them. Convert that into an Ionic equation, remembering that you only change into ions the aqueous ionic compounds. Do not ionize the solid ionic compound. Again, pause the video, have a go, and continue when you're finished to check your answer. Right, this is the first line. Note how I've ionized the 3 aqueous ionic compounds. Note a couple of crucial things. Na2 there becomes 2Na+. Similar for Cl2 becomes 2Cl-, and that I've, remember the 2NaCl means 2Na and 2Cl-. I hope no one's just put 2Na+ and left this off. The barium sulfate is not ionized because it's a solid. However, you've then got to cross out these spectator ions, which means the sodium and the chloride ions, and you are left just with that. Right, let's include a bit of data now. Let's say that the sodium sulfate solution, the following concentration, 0.5 moles per decimeter cubed, and you had 50 centimeter cubed of that. The barium chloride, you had 100 centimeter cubed. Concentration doesn't matter because it's in excess. Question is, what mass of barium sulfate would you therefore get? When working this out, don't let the Ionic equation confuse you. You are using the chemical equation only to get ratios. Remember, because the barium chloride is in excess, the moles of that don't matter. So do you think you can work out the mass of barium sulfate that would be formed? Have a go. If you're totally stuck, pause the video and have a go, but if you're really stuck, come back and continue it just for a few seconds and I'll show you the steps you should go through before I show you the answers. Right, if you just wanted the steps, I'd recommend going through those 4 steps in order as shown there. Right, pause the video again, play on when you think you've got an answer and then you can check it. Right, here are the answers. Moles of sodium sulfate will be the concentration, 0.5. The volume of 50 centimeter cubed. Note how I've converted that into decimeters, which you must always when, this is because we're working out moles in a solution. Moles is conc times volume, but volume must be in decimeters, so we've got that. Now, from the equation, we can see it's a 1-to-1 ratio of sodium sulfate to barium sulfate. So moles of barium sulfate is the same. MR is there, and the mass is moles times the MR as shown. So well done if you got that. Next question. What would be the concentration of sodium ions in the solution form? This is harder than C. Again, pause the video, have a go. If you're stuck, continue for a second or so and look at the steps, and then I'll show you the final answer in the end. Right, if you just wanted to see the steps, there they are. That's the hint. Again, pause it, have a go at doing it now, and then play on when you're ready to reveal the answer. Right, there we are. We'd already established the moles of sodium sulfate with 0.025. As a quick aside, just a reminder that when sodium sulfate is present in solution, it will split into its ions, 2 sodium ions and 1 sulfate ion. So for every 1 mole of sodium sulfate, you have 2 moles of sodium ion. Therefore, going back to this, moles of sodium will be double the moles of sodium sulfate, and is that. Total volume is 150 centimetre cubed. We must convert that into decimetre cubed. It's therefore 0.15. And the conc, and by the way, if you put something in square brackets, and it must be square brackets, not normal brackets, in chemistry that is shorthand for concentration. So it's just an easy way of saying concentration of sodium ions is the mole over the volume, and there you are. Brilliant work if you got that. Right, that's only one of 5 things I'm setting you though. So you're not too tired already. Second question here, let's begin with the same type of format. Can you write a balanced chemical equation for that reaction? Pause again and continue when you're done. There we are. No surprise. To learn, I now want the Ionic Equation. Pause again, have a go at that. There's the first step of it. Note how I've ionised the nitric acid and the zinc nitrate. Remember, you always split into ions, any acids or ionic compounds if they are aqueous. So we've got an acid and an aqueous ionic compound. You do not ionise zinc. For starters, it's not an ionic compound, and secondly, it's not aqueous either. So if any of you put Zn2 plus here, be ashamed of yourself, please. Similarly, you certainly don't ionise a gas. It's not an ionic compound, and it's not aqueous. So you end up with this. Obviously, the nitrate ions are the spectator ions and can be cancelled. And there's your final answer, therefore. Right, again, let's give you some data now. 0.8 grams of zinc. The nitric acid is in excess. From that, can you calculate the volume of hydrogen that would be produced? Pause again, continue when you're done. Again, if you just wanted the steps, I've given you the 3 steps there. The moles, once you've got the moles of zinc, the moles of hydrogen, simply use the equation for. Again, always use chemical equations in calculations, not ionic equations. Finally, volume of hydrogen. Pause again if necessary. Have a go at those now. Play on when you've got an answer. And there we are. Note how I've gone to 3 significant figures on this. You need to do the same, please. Moles of hydrogen is the same as the moles of zinc. To get the volume of hydrogen, because it's a gas, we do the moles times 24,000, just because 1 mole of any gas occupies 24,000 centimetre cubed. So you will do that. I'll put 2 answers there. Actually, either of those is acceptable, but why are there 2 possible acceptable answers? Let me just explain. Right, if I do zinc's moles, 0.8 over 65.4, that's precisely what I get on my calculator. I've written 0.0122, gone to 3 sig figs. But the exact figure is what's shown here, which means the moles of hydrogen, to be fully precise, is that. And when you're getting your volume of hydrogen, you can either have used the 0.122 that you've noted down as your answer, times 24,000, or examiners will allow you to carry forward the number on your calculator and just do that number times 24,000. And that's why I've put 2 separate answers. One, the 294 is this number times 24,000. The 293 is literally the sorry, lost my place there for a second. It's literally be 0.122 times 24,000. So either way is acceptable. You can either just do the answer to 3 sig figs times 24,000, or you can do the number on the calculator times 24,000. Either one is fine, but do make sure you're showing you're working out properly. Do make sure you're labelling all your steps and you're putting answers to 3 significant figures. Final part of this, what mass of hydrogen will be formed? Again, pause and have a go. This hopefully wasn't too much trouble. You'd already established that the moles of hydrogen was this, so times it by the mol, which happens to just be 2, and you've got that. Again, 2 possible answers, depending on whether you used 0.122 or whether you used that number. Either of those 2 is fine. Right, pause for a minute, get up from your desk, have a 2-minute break, because you've been working hard. After that, come back when you're ready to continue. Now, question 3, same opening format. There is a word equation. Pause the video and write a chemical equation for that reaction, please. Hopefully come up with that. No prizes for guessing what's next. Ionic equations. And hopefully you lot have had so much practice by now, you're agreeing with me. A lovely ionic equation. There's the first step. Crucial parts of it. Don't ionize the calcium carbonate. It's a solid. Don't forget the 2HCl means 2H plus and 2Cl minus. The only spectator ions in this are the chloride ions, so there is your final answer. Right, let's put some data in again. 1.2 grams of calcium carbonate, 200 centimetre cubed of HCl, which is an excess anyway. Work out the volume of carbon dioxide formed. Hopefully by now you're getting used to this and you should be able to do that. Pause the video, reveal when you've got an answer, or if you want the steps. Steps shown here, hopefully getting used to these by now. Whenever you get these calculations, it's always the 3 parts. Firstly, you work out the moles of the given substance, in this case calcium carbonate, using the data. So moles of given. You then try to work out the moles of the required, in this case the CO2. You use the equation for that. So it's always step 1, moles of given, use data. Step 2, moles of required, use equation. Step 3, answer the actual question. Again, pause and complete the answers. Continue when you've done it. Right, we'll go in for a lengthy explanation this time, because it's very similar to an earlier calculation, but there are the answers for you. Can't stop there though, can we? Way too easy so far. That's you an extra problem. Can you work out the concentration of calcium ions in the solution formed? Again, pause, have a go, and continue when you've got an answer. Okay, now if you want to work out the concentration is always worked out from moles divided by volume. So let's establish the moles and the volume separately first. The moles of calcium will be the same as the moles of calcium carbonate, because basically 1 mole of calcium carbonate forms 1 mole of calcium ion. So that's 0.012. The volume of the solution won't change during the reaction. If you've added 2 centimetre cubed of acid here, the volume at the end will still be 200 centimetre cubed. Therefore, the volume of solution is 200 centimetre cubed, or 0.2 decimetre cubed. The concentration of calcium is the moles divided by the volume. There you are. Right, question 4. Now, I know what some of you are thinking. I know exactly what Alistair's thinking. I know exactly what Albie's thinking. Oh, this is all a bit too easy for me, Phil. I've got all of this. Give us something challenging, will you? Well, just to keep you two quiet, and probably a few others as well, let's set something really hard. Right, Same equation as in question 3. No need to write chemical or ionic equations this time. You are given that data. This time though, giving you data for both substances, not telling you which one is in excess. Now, what I want you to do is work out the volume of carbon dioxide, and furthermore, as you well know from experiments by now, you won't even collect the full volume that you would calculate that you should collect, because you would lose some gas in the first few seconds. So, unless, of course, it's Callum or Bailey doing the experiment, because they mysteriously gain gas during their experiments. But anyway, for most people, let's assume you only get 90% of the carbon dioxide which you would calculate that you should get. What volume of carbon dioxide do you think you would get? Have a go. If you get a bit lost and you want the steps, pause the video now, but play on for a few more seconds to see the steps in a minute and a little bit of a hint. I'm not even revealing the answer at this point for this one, but I will give you a hint. So pause for now anyway, come back if you need a hint. Okay, here's the steps for you. You'll have to work out the moles of calcium carbonate and then the moles of HCl, and then decide which one of those two is in excess. And the one that is in excess is the one you do not use. That's the useless value. This reaction will stop when one of these two reactants runs out. And it's the one that's not in excess that will run out first, and the one that is not in excess will determine the moles of carbon dioxide formed. Now, sometimes you can just simply think, well, the one that's in excess is the one with more moles. But in this case, even that isn't strictly true, because you've got this 1:2 ratio. If, for example, you had 0.5 moles of calcium carbonate and 0.6 moles of HCl, although you'd have more moles of HCl, the calcium carbonate would actually be in excess. Because if you had 1 mole of this and 2 moles of this, neither are in excess. They will both have exactly the right amounts to react with each other. If you add 1 mole of this and 3 moles of this, the HCl is in excess. But if you have 1 mole of this and say 1.5 moles of this, you actually haven't got enough HCl to react with the calcium carbonate. And therefore, 1 mole of this and 1.5 of HCl means calcium carbonate is in excess. So it's for you to work out these two, and then the one that's in excess, cross out the answer. And only use the one that is not in excess to work out the moles of CO2, then get the expected volume if you got, the calculated volume if you like. But then if you only get 90% of what you expect, calculate a final answer then. But as I said, not revealing the answer to this one right now. I want you having a real try at it for yourselves without being too tempted to just look at the answer. If you're really curious as to what the answer is, text each other, see what each other are getting, and see if you agree. I will reveal the answer to this one to you tomorrow morning at the start of the lesson, the same as the other parts of question 4 as well. Now, 4b, concentration of calcium ions in the solution formed. Again, I'll give you the steps if you want. Moles of calcium, volume of solution, and then the conc is moles over, VO. Poor show, wasn't forgetting to put the L. Anyway, that is it. But the volume must be in decimeter cubed, remember. Right. Still not hard enough for you? Well, let's set another part then. What is the concentration of chloride ions in the solution form? This will really sort you out. This is a real challenge for you. This is the type of thing that Alistair and Albie definitely won't be saying is too easy. Neither will the likes of Eva Anna, bet it's too hard for you. Have a go, see if you can get it, see if you can prove me wrong and get the right answer. Right, there is one last thing. Whoa, thirsty work, these videos. Let's stop for a drink of water, actually. Look at this, proper Ice Valley mineral water for me. Oh, wait a minute. What am I about to drink? Is this really a good idea? Let's have a good look at what's in this water, shall we? Let's look at this. Comes with some handy data. It's actually not milligrams per 100 centimetre cubed on this one, milligrams per litre. Calcium conc, 15 milligrams per litre, in other words per 1,000 centimetre cubed or per decimetre cubed, which actually makes it easier. Calculate the concentration of calcium ions in this water in moles per decimetre cubed. That is the final question. We'll make that question 5 again. I'm not revealing the answer to this one until tomorrow morning, so compare your answers with each other. Right, that will do for today. See you all tomorrow. Bye for now.